To see model performance metrics, that is, a number that shows how well the model has performed, we can double-click on test and score and see the metrics here. It says the model is linear regression, and here for linear regression, we can see different metrics. So we have mean square error, Root's mean square error, mean absolute percentage error, and R-square, or also called coefficient of determination. R-square is the most important or most widely or commonly used model performance metric for linear regression because we can compare it on a scale of 0 to 1. For example, for this model, we can see that R-score is 0.615, or let's round it up, 0.62. In percentage, 62%. It shows that 62% of the variance in the outcome variable can be explained by the selected features. Or the other way around, we can say that the selected features, the predictors, can provide us with 62% of the known information, but we still need 38% to have a better model. So we have 62% known variance or information, but we don't know about 38% of the unknown variance. On the left, you can see there are different testing procedures. We can use the cross-validation with tenfolds or train and split. By default, the test and score widget has used train and test split. You can see that the model is repeatedly iterating the testing 10 times. The model has split the data into 70 and 30 percentages. So 70% of the data was used for training linear regression model, and 30% is used for testing the model. We can change these to different percentages. Usually 80 and 20 or 70 and 30 are fine. We can also use cross-validation. If we click on that, the model is going to be rerun, and here we can see some progress. So it was quick, and you can see that the model the R-score has increased to 68%, which is better. With train and test, it is about 62. So what can we say about the model? We can say it's moderately good, but not perfect. Maybe R-score was higher, such as, for example, 80% or 75, it would be much better. But for pedagogical purposes, this is good because we are just showing how to interpret the model performance metrics. Now that we have a predictive model, the next step would be to predict some new values. Suppose that we have a new person, we know their age, their gender, some body, physical measurements. We want to predict that person's body fat. So we need some new data, but we already have some data. We can sample from that. And then we can use our linear regression model to predict some new body fat values. So I close this window. Next, I go to transform and then use the data sampler widget. Data sampler randomly selects some patients from our original data. So we can connect our data table to data sampler. But how many patients? You can double click on that data sampler, and here it says that we are randomly sampling 8%. So 8% from the total body fat data, that would be about 21 patients. So the total number of patients was 252. We randomly select 21 patients. After randomly selecting some patients, I want to predict their values, body fat. So I look at the evaluate and I click on prediction widget. I drop it here. Then I say that my data, the new patient data, is from data sampler. And next, we would need a model to predict because we do have the data. So we want to know what model to use to predict. So we connect linear regression to predictions. Now, if we double click on predictions, we can see the predicted values of body fat. So here, the first column is called linear regression. These are the predicted values. And the next column is error, how much error our machine learning model made. And these are the actual body fat. So for example, if a person's age is 35 and whose weight is 217 pounds and whose height is 73.75 and adiposity is 28.1 and neck measurement is 40.5, chest is 107.5 and other variables, we predict that that person's body fat would be 17.9, which is close to the person's actual body fat, 19. And the difference is 1.1. So the difference between actual and predicted is the error. And we can see that our model is performing somewhat good. For example, if you look at the second person, age is 26, weight is 181, height is 69.75, adiposity is 26.2, and other measurements. Our machine learning model, linear regression, predict that a person with such measurements will have a body fat of 16.7, but his actual body fat is 19. So our machine learning model made 2.3 points of a mistake. The next error is a bit large. Also the next. Here again, we can see that the model we are using, the R-square is about 0.70. Now, if you're interested to know which of the variables has more predictive value compared to other predictors, you can look at the linear regression coefficients. So I close this window. Now, if you're interested to know the coefficients of regression, to know which predictor had a larger effect on the outcome in terms of predictive power, you can go to linear regression widget and add a data table. And in the data table, you can see that what information you want from the linear regression model to appear in the data table. And here you can see that coefficients are selected, so they will appear in the data. So if I click OK, and if you double click on that, you can see that the name of the variables, this is the intercept, these are the features, age, weight, height, etc. And these are the coefficients. So if you want to know, if you are interested to know what are the coefficients in the linear regression model, you can use the data table and then send the coefficients to that table. Now, because this data table has a vague name, I right click on that and rename it to regression coefficients. Again, I double click on that and you can see that this is the intercept of the model and these are the weights for each predictor variable in the model. Some are negative, some are positive. You can see that positive means a positive relationship and negative means a inverse relationship. This ends our demonstration on how to perform linear regression machine learning modeling using Orange data mining software. But before leaving, we can add a description to our model predicting body fat index using physical measurements. Thank you so much for your attention. I hope you have learned how to perform linear regression machine learning modeling using Orange data mining software. Thank you so much.